Hey guys, welcome! Thought I'd put up a little video just before your first day of class to kind of give you an idea of some of the things you might hear as you're starting to get your feet wet with OChem. I think it's important to connect, what you're learning today with what you already know or have already learned. And in addition, connect both of those things to what you're going to be learning in the future. So hopefully some of the things we'll talk about during your OChem journey will be helpful to you in that manner, because as you'll come to find, organic chemistry is really a conceptual science. You're not going to be working as many math problems as you did, say, in general chemistry or your fundamental freshman chemistry class. So it's really important to think about things conceptually, because a lot of this science will be understanding a concept and then being able to explain why it happens a certain way. And it's almost like building a house. In building a house, you really want to start with a good foundation first. So what you're going to be learning in this class during the first several weeks is really going to be laying a good, strong foundation for you to be able to explain a lot of the concepts throughout the rest of the course. Because the things you're learning in the first few weeks will end up being the why behind a lot of what you'll learn later. So with that, let's get started. If you happen to look up the definition of organic chemistry online, you'll probably find something along the lines of a study of carbon-containing compounds. And, that's a pretty good definition, because you will be looking at a lot of molecules with a lot of carbon. But even on a more basic level than that, the heart of OChem is really this guy right here, the electron. Thinking, good, I've seen him before. Yes, but we still have a lot to learn about him. So when you think about the structure of an atom, which is something you're probably familiar with, we think of the nucleus, which is composed of positively charged protons and neutrons. And then we also have the electron. Now in your previous classes, the definition you've probably been given for an electron is a negatively charged particle. However, that's not going to be good enough for us here, so let's go ahead and cross that guy out. So instead of thinking of an electron as a negatively charged particle, a better definition is going to be a cloud with a wave-like character that can be described mathematically. So instead of thinking of an electron as a particle, think of it more as a cloud, that can act as a wave. And what we mean by this last part when it says described mathematically, if you remember from freshman chemistry when you all went over quantum numbers, things like 1s, 2p, 3d, those are just ways we can describe the shapes of those clouds, like where the electrons are, where the electron density is. And you'll come to find the electron, instead of saying that the electron occupies the 1s orbital. A more accurate way of putting that is that the electron is that orbital. The electron is the cloud. It doesn't occupy it. It is the cloud. And we'll see why that's important here in just a minute. Another thing before we continue our discussion to keep in mind is discussion of electrostatics. And a simple way to put that is that when you have opposite charges, like a positive and a negative, they want to be as close together as possible, because that's when they're satisfied. They're not satisfied being far apart, but they want to be right on top of each other. And this is where we come to our problem. Because let's consider the nucleus. It has a particle-like nature. It has characteristics of a particle. We'll represent it here with our tennis ball. So it has a particle-like nature. However, the electron has a cloud-like nature. So we can think of it as being our balloon. And let's just pretend this is our 1s orbital. So the electron is the cloud. If this were a little more spherical, it would be a little more accurate. But you can see how it's surrounding the nucleus. If I were to have put the tennis ball, like before I blew it up, right in the center, of our balloon, this is kind of the cutout that you'd see. You have the positively charged nucleus surrounded by this cloud. So think about our nucleus being right in the middle of the balloon. But we know from electrostatics that in order for this to be electrostatically satisfied, those charges want to be, right on top of each other. But the problem is, no matter how much you push and prod and poke, you can't get this cloud to collapse down completely on top of our nucleus. Because ideally that cloud would come down and boop, collapse on top of the nucleus. But because the electron has a cloud-like nature, it can't completely be on top of the particle-like nature of the nucleus. So they're never going to be completely satisfied. And that's what leads us to bonding, and that's what leads us to OChem. Alright, well, just a little something to get you thinking. Good luck on your first day of class. See you later.